Let's get started on Chapter 11, the Dynamic Host Configuration Protocol. In this chapter, we will discuss static IP addressing, DHCP server, DHCP scope, options, automatic private IP addressing, client reservations, designing the DHCP infrastructure, DHCP fault tolerance, IPv6 and DHCP, and DHCP relay agent. As you know, TCP/IP is a protocol that allows for communication between computers. And when we configure TCP/IP, we go up to a workstation and we assign an IP address. We go up to each computer and we give the computer an IP address, a subnet mask, and a default gateway, and we will discuss DNS server later on in this class. This is called static IP address assignment. Static IP address assignment means you walk up to each computer to issue it an IP address. So I go to this computer, I give it an IP address. I go to the next computer, I give it an IP address. I go to the next computer, I give it an IP address. We have 5,000 computers at CCBC. So for us to walk around to each individual computer to give it an IP address would be awfully labor intensive, and it would be prone to error, because when you're typing in that many IP addresses, you're going to make a typographical error sooner or later. So the solution is to use DHCP, the Dynamic Host Configuration Protocol. The Dynamic Host Configuration Protocol automatically issues IP addresses to workstations, and this is called Dynamic IP Addressing. With the Dynamic Host Configuration Protocol, you do not walk up to each workstation and type an IP address. The DHCP server has a group of IP addresses, and this is called a scope. So when you turn on the DHCP client, it requests an IP address from the DHCP server, and the DHCP server pushes down the first available IP address. The client requests an IP address, and the DHCP server sends an IP address. When we configure a DHCP client, we are configuring the workstation so it will request an IP address from the DHCP server. To configure the workstation to get its IP address from a DHCP server, we select the radio button that says Obtain IP Address Automatically. So when we power up the workstation, it requests for an IP address from the DHCP server, and the DHCP server issues the client an IP address. Let's now look at DHCP options. The DHCP server pushes down IP addresses to workstations, but another variable that it pushes down is default gateway, DNS server, and DNS suffix. These variables are called options. The DHCP server pushes IP addresses down to the workstations, but it also pushes other variables such as default gateway, DNS server, and domain name. These variables are called options. So let's look at deploying a DHCP server. First, we install the DHCP server role, then we create a scope, we specify the lease duration, and then we add the options. To deploy the DHCP server, we go to Server Manager and select Add Role. We go into Server Manager. Under Manage, we select Add Roles and Features. We click on Next. We select Role-Based or Feature-Based Installation. We select the server onto which we are going to install DHCP, which is Server 1, followed by Next. We then click on the checkbox for DHCP Server. We click on Next, and it tells us these are other features that are required for DHCP Server. Do we want to install them? And we say Yes, we click on Next, and then it gives us a brief description. The DHCP protocol allows servers to assign or lease IP addresses to computers. We click on Next, we click on Install, and it installs DHCP. And now we can see that DHCP is installed on this server. To create a scope, we go over to Tools, and we click on Tools, and we slide down and we select the DHCP Management Console. In the DHCP Management Console, I expand DHCP, and on Server 1, you can see there are no scopes. A scope is a range of IP addresses assigned to computers requesting a dynamic IP address. So to create a new scope, we right-click and we select New Scope. This wizard helps you set up a scope for distributed IP addresses to computers on your network. We click on Next. I will give the scope a name, such as Scope 1, and click on Next. Then I will specify the starting IP address. In this example, it will be 192.168.100.100, and an ending IP address, which will be 192.168.100.254. So I will be issuing 154 IP addresses. Notice the subnet mask is a Class C subnet mask. It's 255.255.255.0, or you could just say it's a 24-bit subnet mask. I click on Next, and it asks me about exclusions. We will not add exclusions, followed by Next. It then asks us what we want the lease duration to be. The lease duration specifies how long a client can use an IP address from this scope, and the default lease duration is 8 days. If after 8 days the DHCP client is still up and running, it will re-request the same IP address, and it will get the same IP address. If, however, the computer is turned off, if the client is turned off, then after 8 days, the DHCP server will be able to issue that client's IP address to another DHCP client. Click on Next. It asks us if we want to configure any DHCP options. We will configure the DHCP options later. I then click on Next, and it says completing the new wizard scope. Before clients can receive addresses, you need to do the following. 1, add any specific scope options, and 2, activate the scope, which we will do. I click on Finish, and there is our new scope from 192.168.100.100 to 192.168.100.254. These are the IP addresses that will be pushed down to the DHCP client. Now let's look at DHCP options. The DHCP server pushes other variables besides IP address down to the clients. It pushes down the IP address of the default gateway, the IP address of the DNS server, and the DNS suffix such as ccbcmd.edu. To configure scope options, we go to the DHCP Management Console, and under Scope Options, you can see there are no scope options. So let's right-click and select Configure Options. The first option we're going to select is the IP address of the default gateway, and another word for default gateway is router. So we click off on the checkbox for option 003, and then we type in the IP address of the router of the default gateway, click on Add, click on OK, and now the DHCP server will now push down to the clients not only IP addresses, but also the IP address of the default gateway. Let's create another scope. If I right-click and select Configure Options, we can see Scope Option 006 is DNS Server. We really haven't talked about DNS servers, but one variable you have to configure on DHCP client is the IP address of the DNS server. So we will type in the IP address of the DNS server, followed by add and OK. And then a third scope option I would like to create will be the DNS domain name. So I check off on option 015 for DNS domain name, and here's where I can type in the DNS suffix. In our case, it would be ccbcmd.edu followed by OK. So now you can see that the DHCP server pushes down IP addresses to the clients, but it also pushes down other variables called options: default gateway, DNS server, and DNS suffix. Now let's activate the scope. If you look at this scope, you'll see a little arrow pointing down indicating that the scope is not ready to give IP addresses to DHCP clients. So to activate the scope, you right-click on it and select Activate, and now the DHCP server is ready to issue IP addresses to the DHCP client. The DHCP server will push IP addresses and it will push options down to the DHCP client. Now let's look at creating custom DHCP options. We will look at the custom option called PXE Boot. PXE stands for Pre-Boot Execution. And to understand PXE, let's first do a review of what it means to boot a computer. When you boot a computer, you turn it on, and the operating system is pulled off of the hard disk and it's loaded into RAM, and this is the definition of booting a computer. Well, with a PXE boot, there is no operating system installed on the PC. With a PXE boot, you are booting from the network. And a PXE boot is commonly used in conjunction with remote installation and Windows deployment services. So in this example, what we have is a deployment server which has a Windows 7 operating system image on it. And then we have a PC down here that has no operating system on it, and it has a PXE pre-boot execution network interface card on it. So when we turn on this PC, it does not boot to the local hard disk. What it does is it boots from the remote server, and then it does a remote installation over the wire. The Windows 7 image comes over the wire and is installed on this workstation. When we configure the DHCP option for PXE boot, what we're really doing is we are telling the workstation where to get the operating system from. So let's go over to the DHCP Management Console, and if I right-click on IPv4, I can select Set Predefined Options. I will select Set Predefined Options, and under Option Class, I will select under Option Class, I will click on Add, and then I will give it a name such as PXE Client. And then I will specify that the data type is going to be a string, and that the code is going to be 060, because that's the code that you have to use for PXE Client, followed by OK and OK. Then I go down to Scope Options and I right-click and I select Configure Options. And there is the new option that we just created, PXE Client. I click off on the checkbox for PXE Client and I type in the IP address of where the PXE Client is supposed to boot to. And I click on OK. So a PXE boot is when you boot from a remote server, and it's typically used in conjunction with a remote installation. When you configure the DHCP Pixie option, really what you're doing is telling the workstation where to boot from. Now let's turn our attention to automatic private APIPA addressing. As you know, when a workstation powers up, it requests an IP address from a DHCP server, and the DHCP server pushes an IP address down. But what if when the workstation boots up, the DHCP server is unavailable? If the DHCP server is unavailable, then what the workstation does is it generates a temporary IP address of the format 169.254.x.y. This is called automatic private IP addressing. So if you go to a workstation and you type ipconfig and you see an IP address of 169.254.something.something, then you know that this computer is a DHCP client that was unable to reach a DHCP server, so it generated this temporary IP address. This IP address is only good for connecting to other computers in the same network. It will not connect to the internet. But every 5 minutes, the workstation tries to hit the DHCP server. So there are 3 methods by which a client, a host computer, can receive an IP address: manually, which is also called statically, dynamically using DHCP, or if DHCP fails, using automatic private IP addressing. Let's now discuss what's meant by a client reservation. A client, typically, IP addresses are issued randomly. But sometimes you want certain computers to always get the same IP address. And a perfect example for that would be either a router or a web server. So with a client reservation, the DHCP server reserves a specific IP address for a specific computer, so this computer, such as the router or the web server, always gets the same IP address from the DHCP server. To create a DHCP client reservation, we go to the DHCP Management Console, and under Reservations, you can see there are no reservations. The description shows that a reservation ensures that a DHCP client is always assigned the same IP address. So we right-click on Reservations and we select New Reservation. I will give the reservation some name, such as Reservation for Server 1, and then I will type in the IP address that I want Server 1 to get every time it boots up. And then I have to type in the MAC address of Server 1. Now, to find the MAC address of Server 1, I've got to go over to that server. And if I type ipconfig /all, you can see that it shows me that the MAC address, or the physical address, is the number which is burned into the network interface card. So what I do is I type in this MAC address. So that way, this IP address is always assigned to this computer. Client reservations, the DHCP server issues a specific IP address to the same computer each time. And this is the end of part